Okay, guys, so we're going to be starting a new topic today. I just want you to take a look at this slide for a second. What do you see? You see some beetles, you see some birds, you see some moths. And you see that there's different looking types of species of birds and different looking beetles and moths. Today, we're going to look at how a species can adapt due to a changing environment. Think about that. We're going to talk about how a species can adapt due to a changing environment. How do species change? What's happening? What's that called? If you think about mutations, you are correct. So we're going to talk about survival of the fittest. Look at that hawk. Pretty jacked, isn't it? Looks like he's fit to survive. So organisms that are fit are the organisms that reproduce and pass on their genes to the following generation. So it's important for organisms to reach maturity. Maturity, simply defined, is a point in which the species or an organism is able to reproduce. One of our needed primal instincts is to survive and to pass on our genes, and allow our species to survive. So think about it this way. Us as humans need to reproduce. You specifically do not need to reproduce, but as a species, we need to reproduce in order to keep our species alive. So these organisms can pass on the genes that allow them to be successful. And what can happen if there is a gene that causes the organism to be unfit? So let's say it doesn't work out. Let's say there's a gene that doesn't make them successful in their environment. What do you think is going to happen? Natural selection is a process whereby organisms that are adapted to their environment tend to survive and produce more offspring. Simplest term. Organisms that are better adapted to their environment will survive. And by surviving, that means that they're able to produce more offsprings, which allows the species to survive. There's three different types of natural selection. You have directional, stabilizing, and disruptive. So a directional natural selection is that there's one phenotype, one thing that it looks like. So it could be camouflaging, usually the most common way to explain this. So if you have a species that comes in multiple colors for their phenotypes, direction would be that one of those colors is the most successful for survival. So it could be like camouflaging into plants or camouflaging in the sand. And it's going to be one or the other, one of the extremes. One of the stabilizing is when the middle ground, like a good blend of the two extremes, makes them successful or more favorable. And disruptive is when the two extremes, so if we have like white and black, and gray in the middle, it means white and black is going to be more successful, and gray is going to be the least successful. That's disruptive. Directional is either going to be white or black. Stabilizing would be gray, and disruptive would be black and white. So let's take a look at directional. So we're going to talk about beetles. So we have this light green, and we have a dark green. So directional is the extreme phenotype is favored, and they can reproduce successfully. If a species of beetle whose color range from light green to dark green lives in an area of dark green, which color beetle do you think would be the most fit? We're talking about heavy dark green foliage. We're talking about heavy dark green leaves. Which beetle do you think is going to be most successful? The light green, the middle green, or dark green? Well, if we're doing directional, it has to be one of the extremes, which would be the dark green. And as you said, you'd be right. So this whole bell, this part up in the top here, and the whole bell will slide to the right, and showing that there are more beetles that are dark green. So about stabilizing. So stabilizing is when the middle ground is the most successful. Is if the area where the beetle lives is a medium green color, so neither the light green or dark green is preferred. Which beetle would be the most fit? Well, it would have to be the one in the middle. Think about camouflage. Think about if you're playing hide and seek or manhunt. You want to be able to blend into your hiding place as best you could, so you can hide and be able to win the game. So if you are a beetle in this case, you're playing literally manhunt because you are being hunted by predators. So you want to be as best blended into your environment for survival. So here the middle green would work. Now disruptive, as you can see, we have two high curves, one on the left, one on the right. And this is disruptive, which shows that both the two extremes would work best. So this is the light green and the dark green. So remember, both phenotype extremes are the most successful, and the medium will be least successful. In the area where there are patches of very dark leaves and light leaves together, which color beetle would be the most fit or be the most likely to survive? Both the light green and the dark green. They'll be able to blend in and camouflage, and that's going to help them survive. There's more of them surviving. That means there's going to be a better chance of those genes and their genetics to be passed on, which will allow for the species to survive. So peppered moths. So we have two moths here, and this really goes back to the English Industrial Revolution, which is about the mid to late 19th century. And there is the moths. As you can see, you have this grayish moth on the left with some black, but really gray white, and you have a black moth. So up until the English Industrial Revolution, the black moth was best to survive, as it would blend into the trees best and would be picked off by birds of prey. Then the English Industrial Revolution came and it created all this soot, which took on this gray texture. And what can you see? This is what happened. The black moth stood out like a sore thumb. And I don't know if you can see any, but there are a couple gray moths in here, but they're camouflaged in. So would give an easier target. The black moth. And you would see a decline in the black moth and an increased population of the gray moth. On the flip side, after the Industrial Revolution was slowing down, we could see some of the trees take on their natural bark colors again, a little bit darker. And the gray moth began to stick out like a sore thumb, and the black moth was better adapted to this environment, and they were able to survive. And you can see how the black moth is able to blend in. All right, so simple assignment. If you've reached this one, that means you've completed the Ed puzzle. And great job. Very proud of you guys. And we'll talk about natural selection tomorrow. Have a great day.